Hi to all. In this video, we are going to see about some numeric problems on three-phase induction machine. Okay, let us see. Example 1. Obtain the following design information for the stator of 30 kilowatt, 440 volt, three-phase, 6-pole, 50 Hz delta connected squirrel cage induction motor. Main dimensions of the stator: number of turns per phase, number of stator slots, number of conductors per slot. Assume suitable values for the missing design data. Okay, so if they are not given the winding factor kW, we should consider as a 0.96 or 0.955, like that. Okay, so various missing data are assumed referring to design data handbook tables considering size. Okay, specific magnetic loading BAV 0.48 Tesla. If they are not given, we should consider as a 0.48. Okay, and specific electric loading Q is equal to 26,000 AC by AC per meter. Okay, full load efficiency 0.88. Full load power factor cos pi is equal to 0.86. Okay, if they are not given, these are the some of the standard values we should consider. Winding factor is equal to Kw is equal to 0.955. Main dimensions. Okay, we have the we are from output equation. Okay, Q is equal to d square L n S C naught meter cube. So from that, d square L is equal to Q by C naught ns meter cube. So C naught is equal to 11 BAVQ kW into efficiency cos by 10 to the power of minus 3. 11 BAV, we should assume the value of 0.48, that one, and AC value if we 26,000 we assumed, and kW value we assumed 0.955, and this one 0.88 full load efficiency, and 0.86 is a power factor 10 to the power of minus 3. So we'll get the C naught is equal to 99.2 and NS is equal to 16.67 RPS, because the given okay, so 16.67 RPS. D square L is equal to 30 by 99.2 multiplied with 16.6s. Okay, so we'll get T square L value 0.0182 meter cube. Designing of the machine for best power factor D is equal to 0.135 P by multiplied with square root of L. So we have poles, number of poles 6, and L value we should find. So D is equal to 0.135 into 6 square root of 12. Solving for D and L, we will get D value 0.33 m and L is equal to 0.17 m. Number of stator turns. Pi is equal to pi dl by P BAV. So pi dl value, D value 0.33 and L value 0.17 we found here, divided by 6 multiplied with 0.48. That value will be, pi value will be 0.141 Webers. Assuming E phase is equal to V phase, so we should not consider a small losses present. That things we should be neglecting. So V phase value and E phase value are, let us approximately equal. So 440 volt. So T phase is equal to E phase divided by 4.44 F by kW. Okay, so 440 divided by 4.44 multiplied with 50 multiplied with 0.0141 and 0.955. So T phase value will get 148. Okay, number of stator slots. Assume number of stator slots per pole per phase is equal to 3. Total number of slots is equal to 3 multiplied by 3 into 6. So 54. Number of conductor per slot. Total number of conductors is equal to 148 multiplied by 2. This value will be 296. Number of conductor per slot is equal to 296 by 54, 5.55. Assuming 76 conductors per slot. Total number of conductors is equal to 54 multiplied with 6. You will get 324. Revised number of turns per phase is equal to 1.162. One more problem we are going to see now. Okay, example 2. A 15 kilowatt 440 megavolt, okay, 4 pole 50 hertz three-phase induction motor is built with a stator bore of 0.25 meter and a core length of 0.16 meter. The specific electric loading is 23,000 AC per meter. Using data of this machine to determine the core dimensions, number of slots and number of stator conductors for a 11 kV 460 volt 6 pole 50 Hz motor, assuming full load efficiency of 84% and power factor will be 0.82. The winding factor is 0.955. Okay, for 15 kilowatts motor, motor input is equal to 15 by 0.84. So we'll get 70.857 kilowatt is the motor power. Synchronous speed ns is equal to 120 multiplied with 50 by 4 into 60, 25 rps. We have output coefficient C naught is equal to output by b square lns. From that we can find the value of 15 by 0.25 square multiplied with 0.16 and 25. Value will get 60. We have C naught is equal to 11 BAV Q KW efficiency cos pi is equal to 10 to the power of minus 3. That value will be 11 BAV 23,000 and 0.955 and 0.84 and 82 multiplied by 10 to the power of minus 3. We will get 166.42 BAV. Hence, BAV is equal to 60 by 166.42. That value will be 0.36 Tesla. Pole pitch T phase is equal to pi d by p. Pi 0.25 by 4 will get 0.196 meters. L by Tp is equal to 0.815. For 11 kilowatt motor, the design data from 15 kilowatt machine has to be taken. So BAV is equal to 0.36 Tesla, Q is equal to 23,000 AC per meter, L by Tp is equal to 0.815 and C naught is equal to 60. Synchronous speed is equal to 120 multiplied with 50 by 6 into 60. We'll get 16.66 RPS. D square L is equal to Q by C naught NS meter cube. So 11 by 60 into 16.667 is equal to 0.01011099 meter cube. Substituting these values in D square products, solving for D and L. So 0.427 D cube is equal to 0.01099. Hence D is equal to 0.3 and L is equal to 0.125 meters. Number of stator slots considering the pitch gap between 1.5 and 2.5 centimeter. Number of stator slots is equal to pi into d by ts. For slot pitch 1.5 centimeter, so S is equal to pi 30 by 1.5 63. For slot pitch 2.5, SS is equal to pi into 30 by 2.5 37. Hence number of 37 and 63. Assume number of stator slots per pole is equal to 54 will get. Flex per pole will get 7.07 into 10 to the power of 3 Webers. Assuming stator star delta connections for the machines under running condition using delta connections. So hence total number of conductors will get 1836 and number of conductors per slot 18572 by 54 will get approximately 34 and number of stator conductors equal to 307 into 10 into 3 1872. Thank you.